left with x minus 6. Add 6 to both of those. So, I've got that last answer on there. I'm just going to add 6 to it. 5.0149. Here, negative 1.01508 plus 6, 4.98492. Okay, now on these problems, make sure you check both sides, because in this chapter that's not always going to be symmetrical, and you always want the smallest delta. So, what I found are those two x values on the graph at the intersections. This one is at 5.0149. This one is at the 4.98492. And now we still have to find the delta. The delta is the distance away from 5. So you need to know how, oh, this one's easy. So the delta on the left is 0.0149, just subtracting 5. Here I'm going to take 5 minus that. 5 minus the 4.98492, 0.01508. So they are slightly different, and we do want the smaller one. This one is smaller than this one. This is the delta that we're going to use from the left side of the inequality. Okay, so the process is the same as what we did in the last chapter, just the algebra is going to get a little trickier. Now the last part of this problem, consider that like part A, estimate delta. Part B now is to calculate delta for any given epsilon. Okay, so all we're going to do is we're going to redo this process that we did in A, where we were given an epsilon value of 0.01, but we're going to do it for any generic epsilon. So we're just going to carry the letter epsilon all the way through the problem. The same steps we did here, we're going to repeat again. And we don't have to do both sides of the inequality, because we know that the smallest delta comes out on the left side of the inequality. So what am I talking about? So we're going to start out, instead of the triple inequality, we're just going to go with the left side. It's the limit minus the epsilon is less than the function. We know what the limit is. The limit was 6. We're keeping the epsilon generic, so we're keeping it as e. The function hasn't changed. It's 4 minus 2 cube root of x minus 6. And we're going to go through and solve this for x and carry along the epsilon. So it's the same steps I did here. I think it took us 4 steps. First thing we did was we subtracted 4. So I have to subtract 4 from this side. So what I can combine here is 6 minus 4 gives me 2, and I still have this minus epsilon. Here's negative 2 cube root x minus 6. Next thing we do is we got rid of the negative 2 by dividing. You have to divide the whole side by negative 2. I am going to take the time to distribute that division of negative 2. So 2 divided by negative 2 gives me negative 1. And here I'll have a negative epsilon divided by a negative 2. That's going to be a positive epsilon over 2, or you can call it 1/2 epsilon, whatever you like. Flip the sign. Cube root of x minus 6. Now, the next thing we did was we got rid of the cube root. We did that by cubing. Not going to do anything with this. Just going to leave it as that quantity cubed. And then what happens here, those cancel, we're left with just the x minus 6. And then the last step is to add 6 to both sides. So I've got 6 plus the quantity, -1 plus epsilon over 2 cubed is greater than x. Now we are at the spot where we had, right here, 5.0149 is greater than x. If I was to put the 0.01 that I did this problem up here with, if I was to put 0.01 there and crank through this, I would get the 5.0149. But I still need to get delta here. I haven't quite solved for delta. I'm sitting at this spot right here. And what did we do with this number to get to the delta? We subtracted 5. So I have to do the same thing down here. I've got to take this whole thing and subtract 5 to get the distance away, which will be my delta. So what I can combine here is the 6 minus 5, and that gives me 1 plus -1 epsilon over 2 cubed is my delta. So that's the expression for any given epsilon. Oh, sorry, I missed that. Dang it. So here's where I was with the 5. Oh, I can't get both of those on there. Oh, I can't kind of. Oh, not quite. See if I shrink it. Oh, yeah. So this right here is this line right here. So this is taking the place of the 5. I had to get from here to my delta, and we did that by subtracting 5. So I subtracted 5, combined those, got a 1, and there it is. Okay, we're going to do a couple more of these with some trickier equations in the middle. What example was that? 2. No, 1. Example 2. Same thing again. F of x equals 3 plus 2 sine of x minus 1. I want you to find delta if x approaches 1 and we are within 0.3 units of the limit. And we're going to do this algebraically. Okay? So finding that delta, that's the triple inequality. So the first thing you have to do, it doesn't tell you, you have to know, you have to find the limit. If you want to graph it, you can. Sometimes it's helpful. You kind of need the equation anyway. Let me check my mode first. Radian. So 3 plus 2 sine x minus 1. Okay. Zoom trig. And we're approaching x equals 1, so I'm going to trace to 1, enter, and now I know the limit's going to be 3. So if you want to rough sketch that, you can. It's not necessary. So when x is 1, the y value is 3. So we got that limit of 3, and now we're going 0.3 away from the limit. So that means 3.3 and 2.7. A lot of times I'll see people go take that number, that 0.3 away from the x value, and that'll never get you there, obviously. Okay, somebody at the door. Be back in a minute.